in chapter 10.7 and we are in complex numbers. Our first objective is to express square roots of negative numbers in terms of I. So definition, I is equal to the square root of negative 1. And then I squared equals negative 1. I is called the imaginary unit and is a complex number. Using I, we can now simplify negatives inside of square roots. So if you have the square root of a negative number, so negative b, the negative disappears. And at the end, an I will appear on the outside. And they show you the steps on how you get to the point of an I. But the basic rule is if there's a negative inside your square root, the negative disappears, and on the outside of the square root, an I appears. So it says, here's some examples. It says, write as a multiple of I. So we have negative, the square root of negative 300. And we're going to simplify. So the first thing you need to do is take care of the negative inside the square root. The negative disappears inside the square root, and on the outside of the square root is an I. So now we have negative I, the square root of 300. And then we get to simplify 300. 300 is the same as saying 100 times 3. And we know 100 to be 10 squared times 3 again. And then using our shortcuts, you should end up with negative 10i square root of 3. Remember, the square root of 100 is 10. The 3 stays inside. And this is the final answer. So the first thing you need to do is take care of the negative inside the square root. Part B. It says 20 plus the square root of negative 5. We just need to simplify this. So the first thing you do is take care of the negative inside the square root. So you have 20 plus, well, the negative disappears inside and an I appears on the outside. So I square root of 5. And this is the final answer. Okay. So complex numbers and imaginary numbers. This is a complex number. We say it as a plus bi. The a represents the real part, and b represents the imaginary part. So there is a real part, those are the numbers that we deal with every day, and then there is an imaginary part. The imaginary part has the imaginary unit I attached to it. So this is the imaginary part. And this is the real part. Here are examples of complex numbers. So 5 plus 3i, or negative 2i, or even negative 9 minus 4i. 3 examples of complex numbers. Now, how do we add and subtract complex numbers? Well, you're going to do it the same way that you add and subtract real numbers. You combine like terms. So when you add complex numbers, you add the real parts together. So a plus c. These are the numbers without the i's. And then you add the imaginary parts, bi plus di. And you do the same when subtracting. A minus c, the real parts, and then bi minus di. Alright, examples. It says, perform the indicated operations. Write the result in the form a plus bi. So they want your answer back as a complex number. Part A. We have negative 9 plus 2i minus negative 17 minus 6i. Well, the first thing we're going to do is distribute this negative 1 outside of the second parentheses. And you have negative 9 plus 2i. Since I'm distributing a negative 1 in, negative 1 times negative 17 is plus 17. Negative 1 times negative 6 is plus 6i. Now you just combine your like terms. Well, there's your negative 9, and there's a 17. That is 8. And then everything that has an I are like terms. So we have 2i and 6i, which makes that 8i. So this is 8 plus 8i. And it's in the correct form of a complex number. This is the real part, and this is the imaginary part. Okay, part B. Negative 2i plus 6i plus 4 minus I. So this time we are adding. Therefore, we have positive 1s on the outside of all parentheses. So we can just drop the parentheses. And we have negative 2 plus 6i plus 4 minus I. Combine our like terms. 2 plus 4 is 2. 6i minus I is positive 5i. And it's in the form of a complex number, so that is your final answer. So remember, to add and subtract complex numbers, we just combine like terms. Now, how do we multiply complex numbers? Well, multiplying complex numbers, we're going to follow the same rule when we multiply our numbers in algebra. So, I times I, well, we follow the same rules, it will become I squared. And then remember how you multiply your radicals together. So the square root of 2 times the square root of 3. If they have the same root, keep the root, so keep the square root. Multiply the insides together, so 2 times 3, which is 6, and then simplify if you need to. Okay, so they say multiply these together. So the first thing we're going to do is take care of the negative inside the square root. So if there's a negative in the square root, that is the first thing you must do. You cannot simplify if there's a negative in your square root. Okay, so the negative disappears and we get an I on the outside. So we have I square roots of 16 times I square roots of 4. And then we can simplify these because these are perfect square roots. And this becomes 4i times 2i. Multiply them together and we get 8i squared. And then recall that I squared is the same as saying negative 1. So we really have 8 times negative 1, which is negative 8. Some more examples. It says find the product. We have negative 6i times 3 minus 5i. Well, we're going to distribute just like we've always done, or did. So negative 6i times 3, that's going to come out to be negative 18i. And then negative 6i times negative 5i is plus 30i squared. And of course, remember to simplify the I squared. So we have negative 18i plus 30 times negative 1, which means our final answer is negative 30 minus 18i. Remember, put it back in the form of a complex number, and a complex number is written as a plus bi. And then part B, negative 4 plus 2i times negative 4 minus 2i. This time we're going to FOIL. So negative 4 times negative 4, and then negative 4 times negative 2i. So that's 16, and then we get plus 8i. Now we're going to do 2i times negative 4, and 2i times negative 2i. So we get negative 8i and negative 4i squared. The middle terms cancel out, and we have 16 minus 4 times negative 1, because remember I squared is negative 1, and we get an answer of 20. Okay, next objective is dividing complex numbers. So we can add, subtract, and multiply complex numbers the same way we do when we deal with our variables. However, dividing complex numbers is different. The steps for dividing complex numbers. Step 1, you need to multiply the numerator and denominator by the conjugate of the denominator. And then step 2, simplify. So when you divide complex numbers, you need to multiply the numerator and the denominator by the conjugate of the denominator. Now remember, the conjugate means keep the first two terms the same and then change the sign in between. So if I had 4 minus 5i, the conjugate would end up being 4 plus 5i. Keep the first two terms the same, change the sign in the middle. If we had negative 3i, then the conjugate would be positive 3i. So in reality, what you're doing is changing the sign in front of the imaginary part. So the conjugate, change the sign in front of the imaginary part. So if my complex number is 4 minus 5i, changing the sign in front of the imaginary part changes that from a minus to a plus. So now we have 4 plus 5i. If my number is negative 3i, even though I don't have a real part, I have an imaginary part because of the I, so change the sign and it becomes plus 3i. Alright, let's work an example. So it says divide and simplify to the form of a plus bi. So we need to multiply the top and the bottom by the conjugate of the bottom. So it says 4 plus 2i. Well, the opposite of the imaginary part is minus, so that should be 4 minus 2i. 4 minus 2i. And then we end up foiling the top and the bottom. So we're going to have 6 minus 3i times 4 minus 2i. Divide by 4 plus 2i times 4 minus 2i. So again, we get the FOIL. Go ahead and FOIL it out, and hopefully yours will match mine. Okay, so in the numerator we get 24 minus 12i minus 12i plus 6i squared. In a denominator, 16 minus 8i plus 8i minus 4i squared. Now we need to simplify. These middle terms cancel out. These do not cancel out. They have the same sign, so we're going to combine them. Our I squares become negative 1s. So let's see what we have here. We're going to end up with 18, because this is 24 minus 6 from this part. So 18 minus 24i divided by 20. So remember, negative 4 times negative 1 makes that positive 4, plus the 16 is 20. And remember, your answer has to be in the form a plus bi. So we're going to separate our fraction. So divide everything by 20. So we're going to have 9 over 10 minus 6 over 5i. So we would have had 18 over 20 minus 24 over 20i, and then simplify each fraction. And this is your final answer. So when you're dividing complex numbers, multiply the numerator in the top by the conjugate of the bottom. Alright, so let's do another one. Divide and simplify to the form a plus bi. So again, we're going to multiply the numerator and the denominator by the conjugate of the denominator, which means change the sign in front of the imaginary part. That says minus 4i or negative 4i, so we're going to write 4i, which is the positive, and then we're going to multiply. So we have 5 plus 5 plus I, times 4i, divide by negative 4i times 4i. So we're going to get 20i plus 4i squared, divide by negative 16i squared. Simplify, I squares negative 1. So now we have negative 4 plus 20i, divide by positive 16, split them up, and simplify. So negative 1/4 plus 5 over 4i. Okay, next objective is simplifying powers of I. So the first thing you want to do is express the power, the given power, in terms of I squared. Once you have it in terms of I squared, you're going to replace I squared with negative 1 and then just simplify. Recall that if you have negative 1 raised to an even power, it will result in a positive 1. And if you have negative 1 raised to an odd power, it will result in a negative 1. Example, negative 1 to the 4th power is going to come out to be positive 1. But if we had negative 1 to the 5th power, it's going to come out to be negative 1. Alright, examples, part A. We have I to the 46th power. The first thing we need to do is rewrite this so it's in the form of I squared. To do that, divide the power by 2. If the power is even, divide it by 2, and you'll get I squared, but raised to. So 46 divided by 2 is 23. That's going to be the big power on the outside, and the power on the inside is the 2. So you have I squared raised to the 23rd. Now replace your I squared with negative 1. So now you have negative 1 raised to the 23rd. 23 is an odd number, so the answer is going to be negative 1. Let's do part B. I raised to the 400. So the first thing we're going to do, since we have an even power, divide by 2, and you'll have I squared raised to the 200. 400 divided by 2 is 200. Replace your I squared. So now you have negative 1 raised to the 200, and you'll come out with positive 1. And then last one, this time we do not have an even power, so what we're going to do is split this up. So I can write it as negative I times I to the 12th power. You see, we pulled off the negative as well as one I. Recall your invisible power is 1. When you multiply like bases, you add the power, so you'll get back 13. So if you have an odd power, pull off one of the i's. Now you'll have an even power. So we have negative I times I to the 12th. We're going to keep the negative I because we can't do anything to him. Times, this is an even power, so divide by 2. So you'll have I squared raised to the 6th power. Negative I is still there. I squared becomes negative 1 to the 6th. Negative 1 to the 6th is positive 1. So your final answer is just negative I. Okay, so this will conclude our video for 10.7. Please email me if you have any questions.